Hi there, I'm playing with my oldest junk again. This is my almost 100-year-old radio. And today I had a little bit time and I tinkered around with it, and I managed it to supply the necessary voltages, and surprise, it actually works. So it's quite a mess with the cables here. I have 1, 2, 3, 4 different voltages that are necessary. And originally this radio was powered by batteries, or 2 batteries, one for the heater and one for all the other voltages. And well, I don't have a battery like that, but I have a couple of power supplies and other means of supplying power. Well, let's get a little bit into the details and I tell you how I did it. Here is a schematic diagram of the radio, and if you look at the lower right corner, there are the input voltages, plus 120 volts, plus 50, plus H, that's the heater, 4 volt, then minus H and minus A, that's ground, and at the bottom there is minus G, and at the first moment I thought minus G is connected to ground. You see there is something like a connection dot, but it turned out that's only a piece of dirt or something. Maybe a fly has shit there. There is no connection because minus G, that's the grid bias voltage, and that should be between minus 4.5 and minus 9 volt. That's where I take the 5 volt from a USB power supply and connect it well, upside down to get minus 5 volts. This image here comes from the original user's manual, and it shows you how to connect the batteries with the cables and the banana plugs here. And if you look closely, you can see that the minus anode, that's the ground, goes to plus 4.5 volts. So first I thought that's a mistake, but that's exactly how it works, because the minus G connector then goes to the minus pole of the battery. So they do the following. They put the entire ground to 4.5 volts. And of course, minus of the battery is then minus 4.5 volts. And everything else is 4.5 volts lower, but that doesn't matter. We have enough voltage, and if there is a little bit less, it still works. So they make a plus and minus supply from one battery by hooking the ground a little bit on a higher level. Well, probably the most difficult voltage to achieve is 120 volt DC, and for that I took my variac here, that one here. And because a variac is not an insulating transformer, that is pretty dangerous to hook a rectifier and a capacitor directly to a variac, because a variac is only a large coil with a center tap that is movable, so it does not insulate from mains voltage, and if you're unlucky, you probably die when you touch your device. After the variac, I have this insulation transformer here. It is one that converts from 220, 230, 250 to 115 volts. It came from an American device that was converted to run in Europe. Then we have a bridge rectifier and a capacitor, and it is also connected to my voltmeter to set the voltage correctly. So when I turn it on, we see it's 121 volts, and I can adjust that to exactly 120. By the way, it doesn't matter so much. I noticed that when I turn it off, the radio even works with 20 or 10 volts. So yeah, 120 is just what the tubes really need. Then we need 50 volts DC, and I don't have a 50 volt power supply, but I have a lab power supply with 3 outputs, and 2 of them go to 30 volts. So I simply connected them in series with this cable here. And I take 2 times 25 volts. And yes, the result is 50 volts. And then I also need 4 volts for the heater. And the third voltage here on this power supply goes from 0 to 5 volt. So that's perfect. I set it to 4 volt and I have the heater voltage for the tubes. Then we also need that grid bias voltage, which is negative. So it should be between 4.5 and maybe 9 volt, minus 9, minus 4.5. And I thought 5 volt would be good. So I took this USB power supply here, which I made myself. And the USB cable is then split up here. Oh, here, I'm sorry. And by the way, that's one of these Chinese cables where red is negative, -5, and well, black is positive. So if you ever use an USB cable and want to supply something, you cut off one of the connectors. Don't trust these colors. Always check the polarity, because I have already seen a couple of cables where they mixed up the colors. I mean, as long as the cable is complete with plugs on both ends, if they connect it wrong, they connect it wrong on both ends and everything is okay. But if you cut one connector away and you trust that red is positive, well, it could be the other way around. So be careful with USB cables. And that is then connected to the radio, to this grid input here. Okay, let's turn it on. Okay, let's take the variac. We already tested that. 120, that's good. Let's turn the 50 volt on. We have 2 times 25 and the 4 volt for the heaters. Heater switch is off, radio is off, and of course the -5 volt for the grid of the low frequency tubes. Okay, we are ready to run. Okay, so the power button or power switch here turns only the heater on and off, but when the heater of these tubes is off, no current flows, because when the tube is cold, it's not possible for any electrons to flow through the tube. So we turn the heater on, and almost immediately we actually hear my 1 kilohertz test tone from the generator. So that's the fine tuning here. The generator is at 1 megahertz. That's the middle of the medium frequency band. Then we can play with the tube heaters here. If I turn the heater down, signal gets low. So that's the fourth tube, which is not connected. Someone has stolen the second transformer that connects the third and the fourth tube. But yeah, that's working. So now 1 kilohertz is a little bit boring, but I can set my generator for an external source, and I have my MP3 player, and I can modulate that 1 megahertz signal with music, and we can listen to that. Okay, so I want to show you what all these dials here do. So the first large dial is this capacitor here, and that's the first stage directly after the antenna input, which is here. And that is the, well, coarse tuning to the station. So that's a resonator circuit from a capacitor and an inductor, and if you tune that to the right frequency, you get your station. Then we have this smaller dial here, that's the feedback loop, and if this coil here is perpendicular to that coil, the feedback is minimum, and if we turn that in direction to parallel, which is the maximum feedback, according to the manual you should start at the minimum and then tune a little bit higher until your sound gets better. But if you hear this, that actually means you turned your radio into an oscillator and you won't receive anything, and in fact you are sending out a frequency through your antenna and you disturb everyone that lives around you. So you should absolutely avoid this situation. So here I don't have an antenna attached, I have my generator attached, and therefore that's not a big deal. And nobody listens to medium wave anyway. Then here is the second stage, also a capacitor with a fine-tuning dial here. That adjusts the second resonator, which is after the first high-frequency tube. And that's the fine-tuning for your station. And by the way, these tubes don't get very warm. In fact, they are almost cold. So not like the more modern tubes that you burn your fingers when you touch it. And of course the last 4 dials, an inner and an outer ring to turn. That's the heater for all 4 tubes, starting with the high frequency tube here, then the Audion, the decoder for the music, and the 2 stage audio amplifier, while the second stage here is not active because, as I said before, someone changed the circuit. So, and of course turning down the heater of the audio amplifier tube decreases the audio volume, of course. So that's also a way to Adjust the volume, you adjust the heater voltage or the heater current, and that has an influence on everything. If you turn the high frequency tube too high, it starts distorting. Yeah, it actually seems to work. And of course, I think the sound of the radio would be better, but my setup with the amplifier that feeds into the generator, that's not optimal. I think the amplifier is a little bit too weak, and I already get distortion at the input signal, so it's not all fault of the radio here. And by the way, there is something else I have to mention, and that's the audio output. The audio output here is for headphones, the other one is for loudspeakers. That's when you need the fourth tube. I guess nobody has ever listened with a loudspeaker, only with headphones, and therefore you don't need 4 tubes, you only need 3. This is made for a headphone with an impedance of about 4 kilo ohms. So of course I don't have a 4 kilo ohm speaker or a 4 kilo ohm headphone. So I connected this transformer here, and that's a normal mains transformer from 230 volt to about, I think, 6 volt. And the 230 volt winding here has exactly, or more or less exactly, 4 kilo ohms. So that's a perfect match for the radio. And on the output I have a low ohm coil or winding that feeds directly in this 8 ohm speaker, and it seems to work like, well, not perfect, but it works. And here you see the AM signal that comes from the generator. The oscilloscope is connected in parallel with the antenna input. So that's a 1 MHz signal with music modulation.